We'll learn how to find connected rates of change with the chain rule. Let's look at an example. The radius of a circle increases at 1 mm per second. Find the rate of increase of the circle's area when the radius is 2 mm. The radius of a circle increases at 1 mm per second. So the question is, given dr over dt is 1, find ds over dt. These two derivatives are both d something over dt. So they are both rates of change. How do we connect them together? With the chain rule. We know the area S is pi r square. So using the chain rule, we get ds over dt is ds over dr times dr over dt. ds over dr is 2 pi r. dr over dt is 1. So ds over dt is 2 pi r. When r is 2 mm, ds over dt is 4 pi square millimeters per second. Here's another example. A spherical balloon is blown. The volume increases at 200 cubic centimeters per minute. Find the rate of increase of the radius when the volume is 1000 cubic centimeters. The question is, dv over dt is 200 when v is 1000. Find dr over dt. We know a sphere's volume v is 4 over 3 pi r cubed. Using the chain rule, we know dv over dt is dv over dr times dr over dt. dv over dr is 4 pi r squared. So 4 pi r squared times dr over dt is 200. Therefore, dr over dt is 200 over 4 pi r squared, which is 50 over pi r squared. When v is 1000, r is the cubic root of 3v over 4 pi, which is cube root of 3000 over 4 pi. Therefore, dr over dt is 50 over pi r squared, which is 50 over pi cubic root of 3000 over 4 pi squared. This is 0.414 centimeters per minute. In this class, we learned how to find connected rates of change with the chain rule. dy over dt is dy over dx times dx over dt. You can change x and y to any other two related variables.